Dear students of class 11th, Assalamu alaikum wa rahmatullahi wa barakatuh. So in the last lecture we have discussed the work energy principle. As I have told you, there is one more method which is known as calculus method, by which we can prove work energy principle. So today's topic is again work energy principle. Work energy principle. So today we can derive the relation for the work energy principle using calculus method. Calculus method. So now you must know how to find the relation for the work energy principle. So work energy principle is work done by a force on a body is equal to the change in kinetic energy. So actual relation is W is equal to Fs is equal to 1 half of mv square minus mu square, right? This relation gives work energy principle. Work done by a force on a body is equal to change in its kinetic energy. How to find this relation? Using the calculus method. So simple. Work done by a variable force on a body is dW is equal to F dot dx, which is equal to F dx cos of theta. F dx cos of theta, where theta is the angle between force and displacement. Now, if the body is displaced in the direction of force, then what is angle theta? That theta is equal to 0 degree. Implies cos of theta is equal to cos of 0 degree, which is equal to 1. So our expression will become, it is F dx. Now according to Newton's second law, since F is equal to ma, so we can write dW is equal to ma dx, where a is acceleration. Now a is equal to dv divided by dx. Sorry, dv divided by dt, a rate of change of velocity. So we can write it as dW is equal to m dv upon dt into dx, or we can write it as dW is equal to m dx upon dt into dv, dx upon dt into dv. So dx upon dt is equal to velocity, so dW is equal to mv dv. Now we have to find the total work done. Total work done is obtained by the process of integration. So total work done when velocity changes from u to v is W is equal to integral of dw, which is equal to integral of mv dv, where velocity changes from u to v, that means limit. So we can write this expression as W is equal to m is constant and v varies. So it is m integral of v dv from u to v. So W is equal to m, this is v square divided by 2 from u to v, right? Because integration of v is v square divided by 2. So W is equal to m into v square by 2 minus u square divided by 2, using the upper and lower limits. Or W is equal to 1/2 of mv square minus 1/2 of mu square, which is equal to kinetic energy final minus kinetic energy initial, hence change in kinetic energy. So this was the calculus method to find the expression for the work energy principle. Now three cases arise here. Three cases. Number one is W is equal to 1/2 of mv square minus 1/2 of mu square. When u is equal to v, that is no change in kinetic energy, no change in velocity. No change in velocity. So we can write here W is equal to 0. So when a body moves with uniform velocity, then work done or change in the kinetic energy is equal to 0. Work done is equal to 0. So we can write here work done by a force is 0 when there is no change in kinetic energy. So इसके लिए आपके पास एग्जाम्पल है यूनिफॉर्म सर्कुलर मोशन. Uniform circular motion. That means force is acting on the body, but there is no change in the kinetic energy, hence work done by the force is 0. That is work done by the centripetal force is 0. Centripetal force is 0. Right? Second case आपका होगा W is equal to 1/2 of mv square minus 1/2 of mu square. So if u is greater than v, you will get w, तो ये ग्रेटर है और ये स्मॉलर है, m दोनों में सेम, u is greater than v, 1/2, so we will get here w is equal to negative. That means if initial velocity is greater than final velocity, initial velocity is greater than final velocity, that means there is decrease in the velocity. So when there is decrease in the velocity, the work done by the force is negative. So when there is decrease in velocity, then work done by the force is negative. For example, हम यहाँ पे एग्जाम्पल देंगे, when a body is projected upwards, when a body is projected upwards, right? What is the work done by the gravitational force? अब आप खुद समझ लीजिए, when a body moves upwards, क्या इसकी velocity decrease हो जाती है या increase हो जाती है? Decrease, because it rises up to a certain height and then it falls backwards. So when a body is projected upwards, velocity decreases. Hence, work done by gravitational force is negative. And our third case will be W is equal to 1/2 of mv square minus 1/2 of mu square, right? Now if v is greater than u, in the expression there 1/1 m, v is greater than u, that means we will get here w is equal to positive or negative? Positive. So this is positive work done. So when v is greater than u, that means the velocity of the body increases. When the velocity of the body increases, then the work done by the force is positive. So when velocity increases, then work done by the force is positive. Similar example हम यहाँ पे भी quote कर लेंगे. When a body drops, when a body falls or falls from a certain height, what happens to its velocity? As it accelerates, because that is known as acceleration due to gravity. So it accelerates. That means its velocity increases. Then work done by gravitational force, GF means gravitational force, is positive. So these were the cases when the work done is positive, or when the work done is negative, or when work done is zero or no work is done by the force. So now you know When there is no change in the velocity of a body, then there is no work done. When velocity increases, then there is positive work done. And when velocity decreases, then there is negative work done. Now, a simple relation, but it is very important. Relation between kinetic energy and momentum. A relation between kinetic energy and momentum. Here P is momentum, kinetic energy and momentum. So let E is equal to kinetic energy, so E is equal to 1/2 of mv square, right? Now, how to find the relation between energy and momentum? So we will write here E is equal to 1/2 of, हम यहाँ पे लिखेंगे m स्क्वायर v स्क्वायर डिवाइडेड बाई m, क्योंकि हमने m से मल्टीप्लाई भी किया है न्यूमरेटर को और डिनोमिनेटर और डिवाइड भी किया है इसको, यानी इस एम वी स्क्वायर को हमने m से मल्टीप्लाई भी किया है, डिवाइड भी किया, एक m और एक m हम यहाँ पे कैंसिल कर सकते हैं. So we can write it as mv whole square divided by m. But we know mv is equal to p, so we will write here E is equal to, sorry यहाँ पे 1/2 होना चाहिए. So it is mv square, that is p square divided by twice m. So energy E is equal to p square divided by m. So we can write here energy is, kinetic energy is directly proportional to the square of the momentum. Square of the momentum. And it is inversely proportional to the mass of the body. E is inversely proportional to the mass of the body. Right? So if momentum of the body increases or it becomes double, the kinetic energy will become 4 times, because it is directly proportional to the square, and it is inversely proportional to the mass. If mass decreases, kinetic energy increases. If mass increases, kinetic energy decreases. So this is the relation between kinetic energy and momentum of a body. एक सिंपल सी एग्जांपल हम यहाँ पे कोट कर लेंगे. A bus and a car have same momentum. Bus and a car have same momentum, right? Which of them has greater kinetic energy? Which of them has greater kinetic energy? तो आप क्वेश्चन की तरफ देख लीजिए. बस और कार, रिलेशन में हमें मास है, मोमेंटम है और एनर्जी है. अब दोनों बॉडीज को जब देख लेंगे, कार का मास कम होगा, बस का मास ज़्यादा होगा, लेकिन यहाँ पे इसने कंडीशन दी है दे हैव सेम मोमेंटम. जब इनका मोमेंटम सेम होगा तो काइनेटिक एनर्जी किसकी ज़्यादा होगी? क्लियर सी बात है, P is constant. So here only the energy depends upon the mass. Larger the mass, smaller will be the kinetic energy. Smaller the mass, larger will be the kinetic energy, right? तो अब काइनेटिक एनर्जी किसकी ज़्यादा होगी, अब आपको ये क्लियर हो चुका होगा. सो kinetic energy of core will be greater than bus, right? Next, relation between force and kinetic energy. So we know W is equal to F into S, which is equal to 1 half of mv square minus 1 half of mu square, right? Or we can write here F is equal to 1 half of mv square minus 1 half of mu square divided by S. S को यहाँ लाइए, divide हो जाएगा. So this gives a relation between force and kinetic energy. So this was work energy theorem and a brief description for the positive, negative and zero work done, and a relation between kinetic energy and momentum, right? So in the next lecture we will inshallah discuss potential energy. Okay, thank you.